We are going to work on our double replacement reactions, and to start out we have to learn how to decide if this reaction will actually happen. So here we have two compounds and they form two compounds. Unlike our single replacement, which has a single element in a compound, single element in a compound. Two compounds. And in order to decide if this reaction will happen, we're going to use our solubility rules. Now, one thing to note is we're always going to write out the full reaction and then decide if it's a no reaction. So let's see how we do that. The first thing you need to do is pull out your reference sheets, and we need to take some notes on that. So here's your reference sheet. In this box is our solubility rules, and it is broken down into soluble compounds and insoluble compounds, and it's all listed by its anion, or the end of a compound. Okay, now soluble compounds means they dissolve in water, so they are always going to use AQ as their state symbol. Insoluble compounds are not soluble, and they form a precipitate, which is a solid, which is why there's an S. Do not confuse S with soluble. S means solid, AQ means soluble. And basically all these things are soluble. Nitrates, acetates, chlorates, chlorides, bromides, iodides. A few of these have exceptions. So when I see any nitrates, acetates like magnesium nitrate, sodium nitrate, it's going to be soluble, okay? But I do have to check for the few exceptions. So for instance, chlorides are all soluble. So sodium chloride, which is table salt, is soluble. But if I have silver chloride, AgCl. So here's my chloride, that's at the end. I look up my chlorides. Ag is an exception. So chlorides are all soluble except with silver, and that forms a solid precipitate, so you would put an S by there, where sodium chloride would be AQ. Why? Because chlorides are all soluble except silver, mercury, and lead, and that is not an exception, so it is soluble. Okay, so that's the first half of the chart. The second half of the chart is the same way. It goes by your anions, sulfides, carbonates, phosphates, hydroxides, and chromates. And these guys are all insoluble, which means they form precipitates that are solid, okay? But they do have some exceptions. So these are the exceptions. So if I had ammonium sulfide, it would be soluble because it's an exception, okay? Versus, let's say I had iron sulfide. Iron sulfide is insoluble. Iron is not an exception, so it stays on this insoluble chart. So our chart is broken up in soluble compounds and insoluble compounds with exceptions listed. Okay, so we are going to take some notes on this. Double replacement reactions are also called ionic reactions, and we're going to use solubility rules to see if they will happen. And today is just going to be an introduction on that. So will it happen? Question mark. Use those solubility rules. Okay. AQ means it's dissolved in water and it will be soluble. S means a solid precipitate will happen, and it will not dissolve, it's not soluble, it forms this precipitate. If we have a precipitate, that means a reaction happened. If all of our products are soluble, that means we have a no reaction, and we'll explore that tomorrow. So let's look up a few examples. Remember what I said was we're always going to look up the back end, okay? So I have silver nitrate and I have silver chloride. One of those is soluble and one of those is not. How did I determine that? Well, I took my solubility rules here, okay, and I have nitrate, okay, is the end. So I look up my nitrates here. They are all soluble. They're in this soluble box, and there are no exceptions. So nitrates are all soluble. So I put an AQ. Soluble means they can dissolve in water and turn into an aqueous solution. Silver chloride, I'm going to look up the chloride part because we're looking up the end. Here's my chloride. And it says that chlorides are soluble. I need to check if silver is an exception. Over here, silver is an exception. That means even though chlorides are soluble, if it's with silver, it's insoluble. It forms a solid precipitate, and I would put an S there. Okay? My next two examples are magnesium carbonate and sodium carbonate. So these both end in carbonate. So when I look here, my carbonates are in my insoluble box. So that means they would form that solid precipitate. And we would check to see if there are any exceptions. Magnesium carbonate. Carbonate's insoluble except with ammonium, lithium, sodium. So this is not an exception, so it is insoluble. I put an S. Sodium carbonate. Here's my carbonate. It's all insoluble unless it's with these four, and sodium is an exception. That it means it will form a solid precipitate, and that is AQ for our solid precipitate. Okay, so soluble, insoluble, solid, and a lot of times it's PPT. That means precipitate. Okay, so if it forms a solid, we have a precipitate. Okay, so now what I want you to do is you don't need any more in your notes. I want you to check your understanding using these guys right here. Okay, let's get that over. Okay, so here are your examples. Can you tell me if they are soluble or insoluble? Well, this is sodium sulfate. Sulfate's my ending, so I'm going to go and look up sulfates. They're down here. Sulfates are soluble unless they're with these guys. Is sodium one of those exceptions? Sodium's not listed here, so it is soluble. Okay, potassium sulfate. Again, we're at sulfates. It's with potassium. Oh, I'm sorry, I lied. Calcium sulfate. Calcium sulfate. So here's our sulfates. Calcium is an exception. Sulfates are usually soluble unless it's with calcium, so that would form that solid precipitate. Okay, this is lead, and C2H3O2 right here is an acetate. So here it says acetates are in my soluble box, and there are no exceptions, so all acetates are soluble. You would write AQ. Potassium phosphates. Where are my phosphates? Phosphates are down here. They're in the insoluble box unless they are with ammonium, lithium, sodium, potassium. So potassium is an exception. So even though phosphates are usually insoluble, potassium is an exception, which would make it soluble. So I write the AQ here. So here we have the answers that we just went over. Magnesium hydroxide. Okay, down here are my hydroxides. They're in my insoluble box. Magnesium is not an exception. So magnesium hydroxide is insoluble. It forms that solid precipitate. And then we have lithium hydroxide. So here's my hydroxides. Hydroxides are all insoluble except when they're with lithium. So even though hydroxides are usually insoluble, my lithium's the exception. It will be soluble, and rewrite the AQ. Okay?